So what is PIM? What causes it? Why is it important? What does it mean from an ROI perspective? And how do we detect it and resolve it? Well, I'll tell you what PIM is not. PIM, the operative word here is passive. PIM stands for passive intermodulation interference. As opposed to active interference, when we have a cell site and we're getting active interference, we're getting signals from another cell site coming into the base station and causing signal interference. With PIM, PIM is noise generated from devices within the base station itself. So for instance, if we are transmitting a signal from the radio out through the antenna, if that signal is interfered with by any kind of materials in the RF path, it generates harmonics, which generates interference, and that's PIM. Okay? You can see that from top to bottom, we have potential PIM sources. Where there are connectors, where there are joints, where there's potential for corrosion. These are all sources of noise generation that create interference and degrade our signal at the site. Externally, we can actually have PIM generated from guy wires, for instance, signals bouncing off guy wires, from the tower itself, even things like inline surge protectors. Antennas themselves can be a source of passive interference. Okay? A lot of it may be caused by the installation itself. If connectors are poorly torqued, stress factors are introduced, there's contamination that's introduced at the time of installation. That doesn't really show up until much later in the performance of the site. There are test techniques that are specific to looking for and mitigating PIM, and certainly you have to have high caliber, specifically designed products to do the job.
Essentially, the title here is Challenges for Third and Fourth Generation Networks, as we're all too familiar with. One of my objectives today was to give you a broad but basic comparison of two issues. We're talking about PIM, obviously, on the bottom there, but much of the confusion out in the field right now, certainly at the operator level and at all technical levels, is a comparison of return loss and PIM. And I'm here to tell you that they're not related at all. They're two separate issues, two separate problems, if you will. In a nutshell, return loss, or sometimes called SWR, as a standing wave ratio, is really a measurement of transmission propagation efficiency. It's something that has been characterized up to now with very standard, well-known test equipment out in the field. Again, just to be a little more descriptive on it, transmission line, really a very basic formula. You're looking at a Z0, which is 50 ohms, and is really a constant, that 138 divided by the square root of K, which is the permittivity of the conductor. So if you look at that as a fixed number, times a ratio of the two diameters of our cable, the center conductor and the outer diameter. Showing you here now, there's no real connection between PIM and return loss. If you look at this graph, it's a very demonstrative graph, if you will. We vary the PIM. The blue trace is the PIM level, and as you can see here, it varies all over the place. This is done for the purpose of a demonstration here to show the effect. If you look at the very bottom of our graticule, we have a red trace which shows no movement at all. So in other words, the return loss value did not change while the PIM values were all over the map as far as degradation.
One of the things we discovered, we're in North America. We're very much about the business and the competition of the world. We do business in Europe also, where they're much more willing to share for whatever reason. And what we've done with them is we've gone out to a large number of sites across a large number of countries. We've actually taken data to see what happens when you do test for PIM, because their sites aren't performing as they expected them to perform. There was no real surprise, but basically the return loss problems were very small. The reason for this is for the last 10 to 15 years, return loss has been the standard for measuring the quality of the installation of a system. It turns out that PIM is as much caused by the fact that things were not put together correctly, and when the weather changes, the wind comes through, they see their system performance degrade versus time. It's what I call an intermittent problem, and if you're in engineering, intermittent problems are ones that you hate the most because you can't repeat them when you go back out there. And so what we're seeing here is we've got to come up with a method, a test methodology that allows people to surface these problems, and then the hardest part is to get them to take action on those problems. Just to quickly go over what this is a passing number. This is the spec line. By doing a dynamic test, which in this case is just tapping it with a wrench, the guy on the top of the tower takes a wrench out of his tool bag and he taps it in multiple locations. Across time, he may see a PIM failure. One strategy would be to erase that screen, start over, and not tap the thing, not do the dynamic test. In a time-constrained market, that can happen.